action in front of it, though.
They lied.
You think so? Okay. All right. I like the technical terms we're using. I like that, Gianni. I like that a lot.
Too far back.
So, once again, schedule is today. We're doing part 2 of Unit 2. I did part 1, second period. I do not think this will take the whole period. I think you'll also have some time to work on your FRIQs some more today as well. Tomorrow, we're going over whatever FRQs you did. The more you did, the better. I would really recommend trying to do all of them if possible. So you can give yourself a score. You can score yourself out of what you completed tomorrow. Then we're going to color. So if you have your own coloring materials and want to bring them, you can. If not, I have coloring materials for you. Yes, it has something to do with AP review. It's not just like coloring in a coloring book. So we are starting off on here. So open it to this page. Lewis structures is where we are starting off.
Yeah.
So, carbon dioxide is what formula?
CO2.
CO2. How many valence electrons does carbon have? 4. How many does oxygen have? 6 times 2 is? So I need a total of 16 electrons. I'm going to put carbon, oxygen, oxygen. And then I'm going to do a quick check before I add in anything else. If I put 3 lone pairs and 3 lone pairs, right? That would give me 2, 4, 6, 8, 10, 12, 14, 16. Would that fulfill the octet rule for everything?
Yeah.
No. Carbon would only have 2, right? It needs 8. It would have 4. So guess what I'm going to have to do?
Double bond.
Double bond, double bond. So 1, 2, 3, 4. 1, 2, 3, 4. Whenever you can't, you have to, it's just about the octet rule.
But like, how do you know it's to do that and not to add like
Because
single
there's
bonds and
they're
a
all
lone pair?
Only one way will work, and if there's more than one way, then you'll see again on the next page, formal charge,
Okay.
right? The formal charge will help you know if you're not sure between the two, whichever one has the lowest formal charge. Okay, NH4 plus 1. So I'm not doing this part. I think you guys are good with that. Nitrogen has 5 plus 4 is 9 minus 1, 8. This should be an easy one, right?
Yeah.
N, H, 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 H. Boom, done. Are octet rules or duet rules fulfilled?
Yeah.
You should do the bracket with a plus for it.
Oh, shoot. You're right.
Oh.
Charge. Well done. Well done. Okay. All right, sulfur trioxide. Try that one on your own. Now let's just do it together.
Yeah, I like it.
Let's just do it together. Sulfur has 6. Oxygen has 18. So I need a total of how many? 24. And when I'm adding these up, I'm just talking about valence electrons, yes? So I'm going to have sulfur, O, O, O. If I would put 6, 6, 6, hold on. That would be 8, 16, 24. Would that work?
No.
No. What? Sulfur would not be complete.
No, you could do resonance to like have a double
No, then
bond.
oxygen. I mean, yeah, we're resonance.
Yeah, resonance.
Res.
A double bond.
If I put, there's lots of things being said right now, right? Can I put a lone pair? I could, but that wouldn't work, right?
Yeah, that was right. Resonance.
Yeah, resonance.
So if I put a double bond here, dot, 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 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. That means that this has resonance because that double bond can go anywhere. Oh, there's no charge on this one. Double bond can go anywhere, so there's resonance there. Last one, PCl5. PCl5. We're going to have an expanded octet here, right? So P, Cl, 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 Cl. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Boom. Done. Increíble. Increíble. Flip the page. I copied it better this time. Copied it better this time. You're welcome. I'm pretty sure that each of you are going to end up with like a ream of paper by the time we're done with this review stuff. So, just a lot of paper. I know. I'm sorry. The staple was better this time. Yeah, but last time that was weird. This like flows better. What is the octet rule? Yep, good answer. 8. When drawing Lewis structures, what should be done with the leftover electrons when the octet rule is satisfied? Lone pairs where? Yeah, lone pairs on the central atom, if possible. Lone pairs on the central atom. If not, what am I probably going to do? Probably double triple bonds, right? Draw the Lewis structure for NO2. So this has an odd, let's say NO2 minus? Period. NO2. So nitrogen has how many valence electrons? 5. Oxygen has 12. So I have 17 valence electrons, right? So if I have N, O, O, how's this going to look?
I don't remember doing this.
A double bond, so resonance and a lone pair.
So if I put a double bond here,
Wait,
2, 4, 6.
that's 2, 4, 6, right? I can only put how many in this oxygen? So 2, 4, 6, 8. How many would put on this oxygen out here? So 10, 12, 14, 16, right? Where is my lone individual little other one going to have to go? There's only one place it can go. It can only go on the nitrogen, right? Yeah. Are you going to see something with an odd number? No, you're not. It doesn't matter which side the double bond went on? No. Yeah, that's just a weird one. I don't know why they even put that in here, but that's how that would have to go. So, really this should have been NO2 minus, right? That should have been NO2 minus, and then we could have put a lone pair there, and then complete the octet rule. NO2 doesn't really exist just by itself. There are elements that can disobey the rule. So give an example of an element that could have more than an octet rule. P, Cl, S, basically anything after P. P and up can have an expanded octet. And then there's some that are lower, and that's basically what? B, BE, LI, right? Because I originally taught you that the rule was BS, right? But then we realized that P is technically there too, so really it's BP. Because the expanded octet rule. I said everything from B to S has to have, but that's not even true. So, I know. What's the equation for determining formal charge? Do you guys remember how I taught you this? Valence electrons minus assigned. Valence electrons minus signed. Or the official one is valence electrons minus parentheses lone pairs, right? or not even lone pairs, lone electrons plus bonding electrons divided by 2. Do you guys remember that?
Oh, so it's like you count up.
It's just the valence electrons minus how many are actually assigned to it. Do this one. This is how I taught you. Flip the page. How many are actually on it?
Like total electrons?
Yeah, but remember, assigned, if it's a bond, it only gets half of the bond. Right? It only gets half the bond. So flip it. So, oh, this copied weird. So down here, it says draw the Lewis structures for the carbonate ion. Include all valid resonance structures. Label formal charges on the structures. So let's do carbonate. Carbonate is CO3 what? CO3 2 minus. So I'm going to have 4 plus 18 plus 2. So I have to show a total of how many? 24. 24. So first one, carbon, oxygen, oxygen, oxygen. On this one, I'd have to have a double bond. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I think that works. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Brackets. Brackets minus 2. So,
In resonance?
Do you always show resonance?
well, we're going to draw all 3. It wants us to draw all 3, right? So then the second version is going to be carbon double bonded to this oxygen down here, down here. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, minus 2. And then the third version is going to be carbon double bonded to the one going down. Oxygen, oxygen, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, still 2 minus. You can kind of see that there's resonance here, right? But the way to check and make sure that these are all valid is by doing the formal charge. So, what is the formal charge? Let's do this one. Formal charge of carbon. So, the way we do this, I'm going to zoom in a little bit. Carbon has how many valence electrons? 4. Minus how many electrons are assigned to it in this molecule? 4. Because there's 4 bonds, but it only gets half of each one of those bonds. You guys remember doing that?
Yeah.
Yes? So 4 minus 4 is what? 0. Let's do our single bonded oxygens, because those are going to be the same. So oxygen has how many valence electrons? 6. How many does it have assigned to it? 7, right? Because it has 2, 4, 6, and one of those is 7. 6 minus 7 is? 6 minus 7 is negative 1. And then let's do our double bonded oxygen. Oxygen has how many valence electrons? 6. Minus how many are assigned to the double bonded one? 2, 4, 5, 6. 6 minus 6 is? 0. So this whole compound has an overall charge of negative 2. Because how many single bonded oxygens are there? 2. Times 2, that's how I get my negative 2. And all of these are going to be the same, right? Yes? So, let's do it for sulfate. So sulfate has 2 possible structures that are correct. One is this, S, O, 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 O. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's one. The other one is going to be S with 1 double bond. Sorry, let me zoom out a little bit. I could also have an expanded octet version of this. So I could have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So using formal charges, figure out which one of those is the best. Oh shoot, I think there might even be another one. We could even probably do this. S double bonded, O. I think this would work too.
Yeah.
I think this will also work. So this would be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6.
Can we make 3 of them double bonds?
No, because I don't think that would add up right. I believe that's all of them. That's all of the... Those are all the possible ones. So figure out formal charge in each one of these and see which one is going to be the best. Did you guys do the first one? Is the first one possible?
Yeah.
I have oxygen. Did you get -1 for your formal charge on oxygen? Oh, wait, it's times 4. It's times 4, so that's -4.
Yeah, so that would be -2.
So -4 plus 2, -2. What about the second one? Okay, keep going. Keep going. Yeah, let's finish it. Sorry. Good question.
Lowest form of charge.
Same charge.
-3 less than 1. You mean like the form of charge or you Choice 32. Oh,
All these drawings are insane. I think that's I know it's always just with the I wouldn't be surprised.
It's negative.
And then this one, I have single bonded oxygen, which is going to be 6 minus 7 is -1 times 2, which equals -2. Double bonded oxygen is going to be 6 minus 2, 4. 6 equals 0. And sulfur is going to be 6 minus 1, 2, 3, 4, 5. 6 equals 0. So all of these add up to -2.
Yep.
So if we went back to the notes when I originally taught this, it said they have to add up to the right number, have the lowest formal charge, which they all have the lowest formal charge, and also keeping the lowest formal charges on the most individual atoms. So which one is that? It's this one. It's this one. Because this one has the lowest formal charge on the most atoms. So this one is the trump. That trumps all of them. Now, is there different ways you could draw this? Yeah. You could draw the double bonds like this, or like this, or like this. It doesn't matter. But the one with the 2 double bonds is going to win, and there's like 5 different ways you could draw
If you
that.
wanted to indicate residency on that, how would
Just
Could you-
lines on it.
You would just put,
well, but how would you differentiate lines on the other two from the one?
you would, if you wanted to, I don't think you really would, but you could put double bond here, like a dot, 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 and a dot, 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 to show that there's only 2 bonds that are switching.
Can you explain that again? What was it? How did that?
This one wins. They all added up to -2, right? This one had a -1 and a 2, right? This one had a -3, a 1, and a 0, right? This one had a 0. This one had the lowest, the most with the least amount. Because this one had the -1 and 0. So this one had -1, 0. This one had a -1 and a 2, right?
No.
This one had a -1 and a 1. So because these two were the least amount individually, that one wins. So you go to individual charges, and then one of them will win. I also don't think AP would make you do something like that. But still good to remember how to do formal charge. They're going to give you something. If they would give you two structures and say which one is it. And you'd figure out formal charge and you'd know the answer very quickly. Flip it. What information is given by the bond order of an atom? Don't overthink this. The number of bonds, right, between 2 atoms. What's the formula for determining bond order? So we did this maybe once, but bond order is equal to the number of bonds this is bonds broken. This is the one that's reactants minus products, right?
Yeah.
So this is bonds broken minus bonds formed, right? So bonds broken minus bonds formed. That's the only one that is reactants minus products. And we know as the bond order increases, the bond strength is going to do what? The shorter the length,
The stronger the strength.
so if I'm adding more bonds from a single to a double to a triple, it's getting how? So it's going to actually increase. Shorter the length, the stronger the strength. We actually talked about that in the first half. You'll see second period. So identify the hybridization of carbon involved in the double bond on the left side of the picture. So on the left side of the picture, yes, there is. That's a carbon.
That's all carbon.
Yeah. Whenever you have a triangle, those are always just carbons. Carbon, 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 carbon. I'm sorry, a hexagon. My shapes are not working right now. I said triangle. Well, I was thinking of 3 sites. My head was thinking ahead. What is the hybridization of that? How many bonding sites are there? I've got a double, a single, and a single. 3 bonding sites. sp2. That's sp2. That is sp2. What is the bond order for the nitrogen atom? So the bond order for the nitrogen atom is going to be sp2. sp2. What's the Vesper shape of the nitrogen molecule?
trigonal planar.
Trigonal pyramidal.
Hey, I swung.
You were close.
Shooter's gonna shoot. Shooter's gonna shoot.
Trigonal pyramidal. Why? What is there technically here?
Lone pair.
There's technically a lone pair there. It said this isn't showing the lone pairs, right? So that lone pair makes it go from this to this.
Great.
Tripod.
If it wasn't on one trainer, it would.
It'd be trigonal planar. Correct. Using Vesper, explain why the mod causes shape. I just explained it. Right? What are they trying to do? They're trying to make the electrons go dispersed. Yes. Flip the page. This is the last page. What is the bond angle of C? Oh, double bonded O. We got to go back. What's the angle?
It's the CO double bond, right?
The CO double bond? Oh, that's this one.
Yeah.
So what is the bond angle of here? 120. That's also sp2, right? It's also sp2. So that's 120. Explain why using Vesper. Because we're just repulsions, right? Okay. Bond type. Single bond has how many sigma bonds? One. Double bond has how many sigma bonds? One. Triple bond has how many sigma bonds? One. Remember how difficult this was the first time we did this? A single bond has how many pi bonds? 0. A double bond has how many pi bonds? 1. A triple bond has how many pi bonds? Remember how I tried drawing them like this and this? Yeah, this is what you need to know. Well, the balloons were the Vesper. I was trying to draw like, because your pi bonds are like this, but your sigma bonds are like this. Remember how I was trying to draw that?
I remember them.
I know. So circle one sigma bond. So a sigma bond, I could circle this. That would be sigma. And if I wanted to circle a pi bond, that would be a pi bond. Anywhere where I have a double bond. How many total pi bonds do I have in this molecule? 1, 2, 3, 4, 5, 6. I have 6 total pi bonds. How many sigma? 1, 2, 3, 4. Wait, I can start over. I'm going to start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, shoot.
Oh, you're right.
Which is going to be what type of bond?
Sigma.
Single bond.
Yeah, I think it's a hydrogen.
So how many is it?
14.
14. Checking.
Oh, come on.
Wouldn't there be a H there?
Why?
It isn't.
Because you got to fulfill the octet rule, right? There would be an H here. There would be an H here. There'd be H's there as well. There'd be H's there as well.
Personally, I would take.
None.
Because there's H's that aren't shown on here. We haven't done a lot of organic. Like, you wouldn't be responsible for this.
I swear these.
I was going to say, that didn't sound right. If I draw those, I think it's supposed to be 17. It's supposed to be 17. You guys know how to count single bonds. That's what matters.
Yeah, why not they We added 4.
So I have,
Oh my god. I swear these rules only count when he wants.
is it 18 or 17? 18. Yeah, it's 18. I'm trying to do it without the answer key. I'm trying to like use my brain.
How'd that go?
Yeah, why didn't they do that?
Why? Because you're supposed to know they're there. Supposed to know they're there.
Visible, but you should know that they're there. You can't see them, but they're there. Trust.
So diagrams are, they don't show everything.
That is